My name is Colin Falwell. I'm a field CTO at Sumo Logic. Been with Sumo for about 2 years. Prior to that, I was a senior product owner around a lot of dynamic language libraries for instrumenting applications in Python, Go, Ruby, C, C++. A lot of partner integrations with Cisco. And prior to that, I led an SRE program and a lot of early shift left stuff for Intuit ProTax. So I've been in the industry a long time. The content that we're going to go through today really centers around what do we have to do to stay competitive in the market, and how do we have to start folding DevOps and SecOps together, and what are the kind of characteristics and traits that we should be looking for in our teams and how we drive things forward. The title of this is it odd to shift left? Odd is not oppositional defiance disorder. Somebody hit me that yesterday, like, why are you talking about that? I'm like, no, it's observability-driven development. Marketing team over here thought that was a catchy phrase. But becoming elite DevSecOps performers is becoming increasingly important, and we're going to talk a little bit about that today and just kind of understand really what's driving it. What are the trends in the industry? Process capability, we're going to talk about some techniques that may have been forgotten that are really applicable to doing these sorts of things. And then we're going to dive into what it means to do observability-driven design, why it's so important, and then how to build some elite performing teams. Shit getting complicated, pardon my French. There's a lot of stack complexity. Everything is accelerating and change. Systems are getting a lot deeper than we've ever had before. Makes log analysis very difficult. It makes log aggregation almost mandatory. It requires uniformity across your CI/CD process and your tool chains. As systems get deeper and deeper, it becomes more and more of an imperative that we trace the environment and we have a way to really correlate everything together. Unfortunately, the reality is that there's a lot of burnout. As things are moving, oh, look at that, it's not going forward. All right, well, they work on that. I'll keep talking. The reality is that there's a lot of burnout. There was a case study that was done a year ago, Red Hat. And they did a survey of like 3,500 customers. And of those customers, about 86% or so, if I'm remembering, were actually running containers, running Kubernetes. Things were great. Things good? All right, cool. So Red Hat did this study, 3,600 customers. And of the 86% that had adopted Kubernetes and containerization, the ones that were actually running in production were about 26%. And of those 26%, over 90 had experienced a security breach within the prior 12 months or a significant outage. That's an astounding number. Is it a technology problem or is it a skills gap? I would say no. I mean, yes, there's probably a skills gap challenge, but really it comes down to, I think, a lack of process and rigor in how you do things in the CI process, how you can break things, rebuild things, stress test, chaos engineer. And so that's what we're going to talk about. Man, I really wish you guys could see these slides. They're fantastic. I spent a ton of time on them. If y'all are in this room, hats off to all of you. Y'all are OGs. I mean, it's Thursday, it's 11:45, we're all the way down the strip, and here you are. I'm honored and really glad that you guys came to listen to me talk. But I really wanted you to see the stuff that I did here. So let's talk about capability of process, and then I'll go through and these slides will be available. We'll hopefully get to a way to match all this stuff back up. But, you know, when we talk about this lack of process and rigor, there's a way to measure statistically how well you're doing around things like process. It's called capability of process. It's a metric. It's called CP. This actually goes all the way back to the Handbook of Industrial Automation, circa like 1929. If you have a process that's capable, a process that's capable can be measured and predicted over a range of values across one or more dimensions. No slides yet. It exhibits low variability, which means that if you're going to measure something, you want to have a specification limit. You want to have an upper and lower bound. You want a performance corridor, and you want to measure high fidelity of that metric over time. And you're looking at how many times that metric has a tendency to jump outside of that performance corridor, either below or above the performance limits. So this idea of process engineering, if you think about this, when we talk about upper and lower specification limits, and we're talking about how many times a metric trends outside of that, what does that sound like? Sounds like service level indicators, service level objectives, burn downs, managing to the nines, right? The law of nines. So if you look at modern SRE practices and doing service level management, it's the same concept. It goes all the way back to 1929. It's still as relevant today as it was then in terms of taking specifications, limits, requirements, and producing something. In this case, we're talking about the voice of the customer. Oh, look at that! In session. All right, go. Get out of my way. Ha! All right. Those are cool. Isn't that, see, I told you, these slides are great, man. We're gonna go back and try this again, but we're gonna do the abridged version. This is the agenda. It's cool. Everything is getting hard. And it's a murder mystery. Like, systems are getting deep. 90% of organizations are dealing with security breaches that go to production with Kubernetes because it's really hard things to do. And we're talking now about process capability and what capability a process is. And it looks something like this. So you've got to know the voice of the customer. And the voice of the customer is just a general term. It could be an actual customer. It could be a persona. But it also could be anything that you want to provide value to. So value stream, right? And then you have to know you have to be able to measure very well the voice of the process. And that's what delivers that value in anything that you're doing. So you're looking at the specification width over process width, that differential, same thing as the upper and lower specification limit, but see what's down there at the bottom. What is that? 6 sigma. I'm not saying that you need to go back to being a black belt, but what I am saying is that you ought to think about data quality. How do you curate data? And that's some of the things we're going to talk about today. You want a high sampling rate for data. If you have a metric that only pops up and gives you a sample every now and then, that's not going to give you any kind of consistency. You want something that has a high rate of return, because you want statistical deviations to normalize out of the data so that you can actually see where deviations are occurring. Because if you're going to have a capable process, what you have to be able to do is say, hey, something deviated. Now I can discern the cause of that deviation readily without a whole lot of exercise. So if I'm destroying Kubernetes clusters and I'm rebuilding them over and over and over, when it breaks, I can really quickly figure out why, because I'm breaking it all the time. I'm destroying it, right? Performance testing my code. If I'm doing it in a way that I'm not having to deal with downstream dependencies, same case. When I make a change to my code and something deviates, pretty good chance that I can go back to the lines of code that I just put in and find the problem, because every time I do a commit, I'm getting the results back and understanding. High data quality. And don't change how you're collecting that data. Make it consistent in how you're doing it. So a good metric is going to exhibit a tight performance corridor. Simple, right? They're going to be predictable. For example, if load increases, I know at what point that threshold is going to be reached when I start to go outside of that boundary. So if you want to improve your capability of process and the things that you're doing within your product development lifecycle, here are some suggestions. You really want to build a framework for metrics and how you discern high value versus supported metrics. You know, maturity models, CMMI, been around for years. Everybody talks about maturity. Maturity implies that you reach some state of nirvana. and you don't have to do anything else because you're mature. But everywhere else in IT you look, that's not how things work, because everything is continually evolving. And so your processes, your capabilities, your ability to execute on doing things must evolve as well. What's the answer for things that evolve? You continuously improve. So if you start to look at your disciplines and your domains and your personas and the things that you're responsible for delivering to the organization, to your company, to your leadership, map those to capabilities, things that need to run very well and consistent and predictable, right? Those are the things that you want to focus on, and you want to figure out what are going to be the metrics that I use to measure and report that over and over and over. Eliminate queues and backlogs. Why would you do this? Anybody want to take a guess so I can take a drink of water? If you're measuring something that's end-to-end, and you're trying to measure process and you're trying to make it predictable, the best way to break predictability is to stick something in a queue somewhere, because you have no idea how long it's going to be in there anymore. So restructure your organization, teams, make it to where you can go straight from something to something else without queue. One state to the next state with as little variability as possible, as automated as possible, is going to be your friend. And then battle test things. Break your code, break your systems, chaos engineer, tear things apart, and make sure you can rebuild. Interesting story. I started doing GitOps just to learn Kubernetes, using GitHub Actions and Flux and some just open source tools, and I built a cluster in a home lab. And I started messing around with it, and I just layering things in, doing a lot of home automation and just having fun with it. And then one day I was like, I wonder if I can, I got the repo, it's all right here. Every time I do a merge, it goes right into the cluster. Task space, Ansible, nuke, destroy the whole thing, wiped it all out. I thought this will be fun. Task space, cluster space, deploy. Did not work. It failed miserably. In fact, it actually took me about 6 weeks to just back things out and untag things and just like layer things back in and figure out where all the dependency breaks were so that I could actually get back into a running state. And then I had to do it again and again and again until I got to the point where I could actually destroy, nuke the cluster, and rebuild it on demand. And now anytime I make a change, that's like an automated process that now runs off the tool chain. We have customers that do this. That's how they chaos engineer. That's how they intentionally break things constantly just so that they understand that, hey, we're in a high state of capability. We can do this. And they don't have to slow down. They don't have to stop. And we'll see in observability-driven development why that becomes so important. So, organizations that have high capability process, here's some of the characteristics and traits and best practices. DevSecOps, business analyst, it's intelligent, continuous, immutable, real-time in terms of data. Data becomes imperative. We've already talked about 6 of them. We talked about the need for high-quality, resilient data. In the organizations that we see they're doing ODD and high capability of process, they're leveraging open source libraries. They're going away from proprietary agents and code bases. Why put a proprietary agent into your stack to collect your telemetry? If you're paying for the agent or you're paying for a proprietary tool chain and you're not building and iterating on something like open telemetry, CNCF, you're renting your telemetry from a vendor. Wouldn't you rather be in a situation where you're actually owning the telemetry and then you're supplying it to your vendor as a partner? That way you can go anywhere you want to with the data. CI, telemetry, pipelines, they're all autonomous, they're consistent, they're declarative. So one way to ship code, one way to build code, one way to analyze code. Doesn't mean that you don't do different things and you don't have 1,000 pipelines, but you got standards across all of them, right? Observability becomes annotated in your code. So observability is code. It's annotated, it's instrumented, it's done with domain or aspect-oriented programming. By the way, that's what you get natively with OpenTelemetry, if you're not running with OpenTelemetry today. Metrics, monitoring health performance of your applications, they're declarative, your environment, they're part of the code. And we'll talk about how that can be done. Dashboards, alerts, alert thresholds, they're all declarative, they're all deployed with each merge. So creating a tool chain and a set of automation that encompasses not just observability, but all of the security needs as well. Control plane is going to evaluate outputs and be able to do things in a more automated way. So with that, let's talk and dive into observability-driven development just a little bit and why it's important. So there's a quote Ron Lieberman came out with a few years ago. He was an engineer at Facebook, and he said, if he's, as a developer, if I'm not getting feedback from the code, I'm going to burn out. That's why we have so much burnout, so much churn, because there's so much time spent troubleshooting, trying to reproduce issues and figure things out, because we don't have consistent data, we don't have standards across the pipelines. The real problem is the lack of the relationship between the developer and production. And we're going to look at a case study a little bit towards the end of this in a few slides that really jumps into this. But you've got to have a tight relationship with production. If I'm developing code and I'm pushing it into production, I don't want to wait weeks to get it into production to get insight back. I want to be able to go straight into production as quickly as possible, and I want that feedback real quickly into what's happening around the feature that I'm deploying. So observability-driven development, I went the wrong way. Well, let's go back. So observability-driven development, the ultimate goal here is to, as a developer, be able to go straight from my laptop to production and leverage the production environment for test. Think about that. That's pretty extreme. It's mixed if, I talk to some engineers who are like, no. UAT, acceptance testing, lower environments, like we put code into lower environments, it's like weeks, months before we, maybe get all that stuff into production. But if you're gonna move fast, if you're gonna innovate, you really have to think about how do we do this? And if you look at the industry in terms of elite performers in Dora, any Dora fans in here? I don't mean Dora the Explorer. There are upstart organizations that are just disrupting markets because they're born cloud native and they're going straight to production. Their production environment is their sandbox, and that's how they operate. And they're disrupting industry that way. And the advantage of actually going to production is that you're going to compress your cycle time. I can go from hypothesis to feedback in under a day. That's what an elite performer can do. You can deploy multiple times per day, lead time for change 24 hours, change failure rates lower than 15%, time to restore service when there is a problem less than an hour. Those are discrete capabilities, by the way. Each one of those metrics is defining a capability within the organization to be able to execute with that kind of process. But it forces high quality data. It's a forcing function to really expose all of your weak processes. If you start testing in production, you're going to find all the things that don't work that you need to fix along the way. So when we talk about building observable systems, building observability into the very fabric of what we're doing, we're shifting that left. And observability is no longer a DevOps thing or an ops thing. It's kind of an XOps thing. So it's FinOps, it's SecOps, it's DevOps, it's BI, data science teams. All the personas in the organization that need data out of the environment, you're moving that left into the exploration phase, and you're thinking about, before I write a line of code, how do I need to observe this information? What's coming through this code? So what you measure, why, and how you measure become incredibly important, and you want to standardize and put some structure around that and find a blueprint for success and then start to replicate that and bring more teams into the fold. And you have to, if you're a developer, if you're not going out and you're not meeting your CISO and you're not meeting your CTO and your CFO and your CEO and building those relationships, how do you know what kind of information they need? And the teams that need it the most, by the way, are the sales ops, the business operations teams that are out there trying to do ETL from 150 different data repositories in IT day in and day out, and are dealing with all sorts of code quality or data quality issues. It's not timely, it's not accurate, it's not relevant at that time. So if you can create an immutable stream of data out of your production environments, all that digital exhaust that's turning out, if you standardize that and make it immutable, now you can just start to funnel all of that data to the teams that need it. So consolidating point tools, all your proprietary tools, embrace open source. Because now you have the libraries in your code to curate all of this data, and now you own it, it's yours. You can wrap it, you can extend the SDKs, you have no ops, so you have a test harness, so you can test your observability as code. Like, it just unlocks all sorts of ability to mature and improve your capability of process around these things. So converge that telemetry around this idea of a unified entity model, which is why I'm up here on stage and why I work for Sumo, because that's what we do. Because when you bring all of these dimensions of data into a common entity model, you can start doing really, really cool things with ML, and AI ops becomes a reality and not just a pipe dream. Standardizing the metadata, the key metrics, logging, implementing tracing, being able to go down to the feature level so that when I do a commit and I do merge, I can trace back to what were the PRs in that merge. When something did drift and deviate, can I go to the build manifest? Can I see what version bumps were done? What got changed? Where's the most likely in terms of dimensional analysis of data? I can go from metrics to deep analysis around the attributes that are changing in the data and do that around the feature level, which is really relevant to the developer. So test-driven development, we're all familiar with TDD. It's kind of table stakes. You know, it's a feedback loop between design and test, and really observability-driven development extends this, where you're defining the expected outcome, you're measuring the outcome, and you're changing features to keep measuring and continually improve and iterate what it means to build observable systems. Now you're getting deploy feedback, and you're actually getting that feedback from a developer perspective as, is that feature doing what I thought it was going to do? Because when I put it into production, I had a hypothesis and I had a metric and I have a measure, and now I'm getting that feedback to say, did it do what I expected it to do? And are we operating and deploying the way that we think it should? So best practices around observability-driven development, and this really comes out of what I see elite DevSecOps teams doing in how they build observable systems. It is a unification of all the data. Open source pipelines, it doesn't have to be entirely open source. There's a lot of customers that do black box proprietary pipelines, but it's all open in the sense of the protocols like OTLP. Understand the voice of the customer. What is that feature intended to do? And really be able to measure that voice of the process and code for as much predictability as you can. This is important. As a performance engineer, I spent a lot of time working with developers and helping them understand how to write software better so that you can predict the outcome in terms of performance, because performance is a leading indicator for all sorts of issues that can crop up. And when you're in deep systems, it becomes even more imperative that you really get this. And that is avoiding lazy calls. You want to have predictable response and request and response. You want to offload heavy workloads to async batch queuing. I have a customer that they actually change the UI when they're busy and their back end can't keep up and do things in real time. They just go into a queuing mode and they're, okay, I'll queue that report for you. We'll notify you when it's ready. So it doesn't penalize the customer experience, but they can adjust, and the systems can dynamically do that from a UI all the way into the back end based on a signaling that they've built into the systems. Because the systems are observable, they're also aware of the downstream and upstream, and they can do all sorts of very interesting things to ensure high customer experience while taking on additional load. So also, when you start thinking about building observable systems, you have to think about, okay, well, how is this going to work in reality, in production? And you can start playing what-if games. What is going to potentially derail me downstream that I depend on? And can you go fix that? Can I do circuit breakers, other design patterns? I did an article on Stack Overflow around this. Careful with these kinds of patterns, because a lot of times those will actually decrease performance worse than it would be if you didn't. So you have to really think about how you jump into those sorts of patterns. But you want to think about, like, how do you look at metrics? And it's not just performance engineering. This goes broader into all of the things that we've been talking around capability of process. Most organizations still that I talk to do this. They have a tool. It brings in tons of metrics. And they have a general alarm that says, hey, if that metric deviates more than 3 standard deviations, alert me. What's wrong with that? The problem with that is that all you're doing is saying, hey, tell me when it changes, absent of context, which is the antithesis of what we're trying to do around performance engineering and having specification limits that are thought about up front. Tell me when it's outside of this, and now I know why it's outside of that, because I'm relating that to why that changed, because I'm thinking through those scenarios earlier in the life cycle. The right way to look at metrics, any metric, is to use the 2 or 3 standard deviations, but that's your width in the performance corridor. And now you're measuring how many times it comes out of that.
Can you share with us what LSL is?
Yeah, LSL is the lower specification limit, and USL is the upper specification limit. So it's the boundary on the performance corridor. Thank you. Great question. So hypothetically, if you wanted to automate some of this, what you could do is in your pipeline and your CI, leverage some API mocks, and you could isolate your services that you write, and you could put it through a breaking test. How many in here break their environments on a very frequent basis? On purpose. That's how NASA does it. Every component that goes into a rocket is tested and tested and tested and tested and tested and broken. You have to know where the ceiling is. You have to know what failure looks like so that you can engineer to fix it and improve it. When you do that, you can do all sorts of great things. If you're responsible for a business that is generating millions of dollars in customer experiences, highly important to you, you want to know what the limits are and how much you can handle. When do you scale out, and what does scale out look like, and what does scale out require of the downstream dependencies, and how are they going to scale out and get that signaling in place? So you have to understand what the specification limits are. So if you're going to set those, if you can isolate your code, I can get my specification limits on APIs just running a ramp to break test. I can do that on my laptop. I don't need another environment. As a developer, I can do that on my laptop. I can mock my downstream services, and I can come up with those spec limits, and then I can annotate that into the code, and then my CI pipeline can actually take that, scan it, and do something with it from a CLI, like go Terraform that into something like Sumo Logic. Automate the whole process. Now when I put that into production, I'm getting the immediate feedback. and I know exactly what's going on because I'll get a Slack message that says, hey, yeah, you're in that limit. It's great. Or, hey, you're trending out of that limit and your burn down is, much lower than you want to be at this point of the month because it's only 5 days into the month and I've got, say, a rolling average on an SLI, and my objective is to stay above that burn line. Oh, I was going to go back to this one more time here. And the idea here is that you break it. You want to look at what time do I trend out of that performance corridor, and then go back 80%. That's really your transactions per second in relation to your response times and those sorts of things, right? So best practices in measuring, define the attributes and make sure that you have those attributes and your log structure, do structured logging if you want, but make sure that you're looking at how information and transactions flow through your environments. Understand the code path and the characteristics of those code paths. And we'll talk more about security in a few as well, but security is just important to be able to shift left and kind of move all of this and the monitoring and the observability for these things into that CI process as well. But you want to look at, how do I standardize taxonomies? How do I look at metrics? How do I do cardinality and those sorts of things? And when you're doing these tests in the CI process, that's a great time to develop your canary metrics to understand what is it that I'm going to actually measure when I go to production? What does it need to look like? Doing top percentile instead of averages. Much better way to look at things, and doing that law of nines, right? So best practices in really doing observability as code. We've got customers that take, like I said, the OpenTelemetry SDK and they extend it. They add additional ways to interact with it, to standardize logging, to standardize attributes, tagging, those sorts of things. And then annotate your performance specs. Make sure that your logging metrics, your span events, code ownership, monitoring, alerting, all that's part of your code base now. It doesn't have to live in a config branch anymore separate. It can actually be brought into the code. And that's great because now the developer actually has control over what signaling is coming back in real time. But you can also terraform it. You can also still put it in the config branch if you're not that mature yet. The point is, make sure that it lives in the code base. That way, if you need to make changes, you're making it there. And when you deploy, you've got an audit trail of where you've been, where you're going with those types of configurations, and you're able to continuously improve it. That's the key. And make sure that you've got the right business relevant data, contextual data in your logs, traces, metrics. Higher cardinality data is better. And if you're working with vendors to do data analysis, you want to find vendors that support the idea of increasing cardinality without increasing cost. And your data should be product and process oriented. It should be very high value, feature driven. You want to use domain or aspect oriented programming. And if you're not familiar with this, basically the idea here is that you can have function in your code that doesn't live, that source code doesn't live in your code. So it makes it very clean to annotate. It doesn't muddy things up where you have a lot of additional code just to get instrumentation out. Keeps it tight, keeps it really clean. Retrofit existing code base only when you have to. So do this for all the net new stuff. Strangler approach, it's a pattern, right? Design pattern, just basically where you're going back into your legacy stuff, all that box of doorknobs we all drag around everywhere we go because we don't know what to do with it or how to get it to the cloud. Only put that instrumentation and standardize on that stuff where you're actually making changes in the hot spots of your code, of the legacy stuff. Logging can handle the rest of it. You can bring all of that stuff along as it goes. So, we've talked about performance engineering. We've talked about observability-driven development, which is this idea of going straight to production and why we want to do that. Let's talk about elite performing teams. And the reality is that the old ways don't work anymore. If you're going to be an elite performing DevSecOps team, you have to look at how much of this can I automate around the dev lifecycle, around the ops lifecycle. Security now has to be a part of this. Why? If I'm shipping multiple times per day, I have a lead time for change less than 24 hours. My change failure rate's really low. I'm moving. I'm accelerating. I'm innovating faster. Security can't be an afterthought. Or you're going to be a statistic. And nobody wants to be a statistic. Elite performers, the lead time for change is not less than an hour. Though I know probably a few developers that will push changes. They'll have an idea and they'll just code it and they'll just shove it into production within an hour. But it's actually a day. That's a typo. But this is what it means to be an elite performer. And why would you want to be an elite performer? This study from last year from State of DevOps report that Google actually bought the DevOps Research Institute. This is the longest running study. If you haven't really looked at it, I encourage you to go check it out because there's some really fascinating information in here, a lot of good insight about the human dynamic and culture and those sorts of things. But elite performing teams have increased from like 18% in 2018 to like 26% in 2021. So 4 years you've seen almost a doubling of teams that are elite, that are doing these things, right? That are measuring these capabilities and they're executing at this speed. They're 50 times more likely in some Gartner and Research 451 studies, 50 times more likely to be able to accelerate market expansion if you're an elite performing team as a company. 80 times more likely to be successful in merger and acquisition. They just went through an M&A. But the point here is that if you can move faster, you can fail faster. You can improve capability faster. And that's key if you want to be able to dominate the field that you're in, fundamentally. I want to be able to get through every cycle as fast as I can because I have a goal of improving these capabilities in the organization. The only way that I can do that is to go through a cycle and figure out what works, what doesn't work, how can I make things more automated, how can I throw chaos into the mix and figure out what breaks, what's brittle, and improve it. I like this statistic the most. If you're an elite performing team, you're 24 times more likely to be able to fully embrace cloud native for what it is. To extract the most value out of cloud native. From architecture, being able to do on-demand self-service, having broad network access, having resource pooling, rapid elasticity. These are things that are going to disrupt the market if you're trying to come in and take market share. You have to have these things. So these capabilities, these performance metrics, the lead time, the deployment frequency, your change failure rate, your time to restore service, all that equates to reliability. These 4 key metrics are just the start. If you want to understand and really see some additional key metrics that are good, and you're in security, we had a lot of hands in here for security ops. Who's been to the GSA website for DevSecOps? Has seen that. If you just go to gsa.gov and search DevSecOps, there's a great list of metrics. Guess what? Those all align to capabilities in the organization. And if you're not measuring those things, how can you ever hope to improve? You don't have to be a governmental agency or working in Fed space to think that, hey, maybe it's a good idea to automate and have a release gate for authority to operate some piece of code in production. Because if I'm going to move this fast, I want to think about all of those things that we looked on that other slide back there. All of that should be baked into the CI process, right? You should be able to have high confidence that you're not going to be vulnerable when you're moving at that speed. And that's one of the biggest problems. That's why it's hard to get that approval mindset to be able to move fast, to be able to innovate quickly, because companies are risk adverse. So you really have to look from an organizational perspective to, like, who can be an elite performer? Who is going to be the elite performing team within the organization? And most organizations that I see today, especially if you're 5,000 employees or more, you really have to break away. You have to get some buy-in from the C-level to say, hey, look, we're going to go and fundamentally start something and do something completely radical. We've got this new project, this new line of business. We're going to go and do it this way. And we're going to build the model. We're going to build that capability. And we need that buy-in. We need the investment to go do that. Once you do that, once you have that blueprint, now you can start to bring more of the organization in line with what it means to be able to do things this way. One of the customers that we work with has done an awful lot of automation in the CI process. I would say 95+% of all of the security insight intelligence is now in the CI tool chain. A lot of things happen. They just have pipelines that are just running, continuously doing all the things that they need to do, providing that data back. But how they got started on this was a few tenets. Rule number one, there will be only one way to build software and only one way to ship software. So the way that they did that was to standardize on project types. So you have a project type for every language that is being developed in the organization. So if you're like using Circle CI or something, for example, your CI YAML file, that YAML file that specifies all of that, that's part of the repository. The SRE team took that and they basically standardized it. Developer can't own it. Now they could go in there and put something in there and override it, that's fine, but it's going to get overwritten very quickly. But they have a CLI that they built, and essentially what that CLI gives them the capability to do is standardize all that across the board. And now they've got a separate repository just for how do you build software and ship software. And so everybody can kind of contribute to that from a CI perspective, and they can make it agile and quick. You're not having to wait on things. You can do PRs. Anybody can contribute. But they're doing everything automated that is needed in the PR and the merge, and they're testing Office. They're testing everything. Like on every commit, they're testing. The entire test suite runs. You should build every time you do a test. You should have an artifact that's ready to be deployed at any point in time on every one of those PRs. And you should be as agnostic to the environment as possible. Maximum portability, because you don't know where this code might be running tomorrow. It might be in a completely different cloud. And you want to be able to focus on how do you get that consistent feedback in the CI process, the output, regardless of the language, should come back to the developer, and it should be standard. And so they put a lot of thought into, well, you know, what kind of information is actually needed? And is the data that's there now, is that good enough? And we'll show you what some of that looks like. Having that short type feedback loop, engineers getting that actionable feedback from the CI tool chain, that's that relationship between the developer and production and everything that is in between. So well-tested code, stored in version control that can be easily changed and deployable at any time. That is the foundation key of things that you need to be able to do to be able to move fast and have a lead time for change less than a day. So the first goal is full automation, hierarchy, and control. Best practices in CI, there are projects. Each project needs a config file, control YAML, for example, that declares the project type. And that type should be supported for all the languages that you have. And then there are repos, and each repo has one or more project types. And you've got to have a way to automate this. Now there's a QR code here Jeff Dickey, the 12-factor CLI, it's a great Medium article on how to extend what you're doing around CI to get around doing these sorts of things. The 12-factor CLI is the strategy that they went with, and the advantages are numerous because now they can do all sorts of things. They can extend what happens in the code scanning and the CI process. They can maintain all of the pipelines, all the repositories. They can add new standards into Java with one command. Standardize it across all the development teams, give everybody the access to those things. Did everybody get a copy of that? If you didn't, let me know. The second goal is to provide that feedback loop. Now, this doesn't just extend from just the CI process. This goes all the way to production as well. So the communications best practices that they focused on is let the author know as soon as possible when something's read, but don't overdo it. That was their rule. That was it. And that was one requirement that they had. They sat down and they spent months trying to perfect that one thing. That's a capability. Measuring satisfaction and feedback, the voice of the customer and the voice of the process, the ability to provide that information in contrast and situ in time, right? So for example, if a job on 20 containers, 18 saw failures, just notify once, roll that up, one notification. And only notify once about all the green stuff. Yeah, it went well. Developers like that too, because, well, is the comm system not working? Like, what's going on? So I want to kind of know when things are good too, but I only need a single notification. They use Slack to do this. Give as much context as possible without overwhelming them. So concise and clear, that was the other requirement. So what they did is for PRs, they just include the link to what branch failed, which repo and which PR, and the failed job in the suite. And for merges, the link to the commit diff, the title and the job that failed, and the top level workflow and the ETs for all the contributors that were in that merge. And then everybody gets the Slack notification, hey, that merge failed. Now that same, what goes into the code base to make that happen from their CLI perspective takes that all the way to the production environment. It does the same thing with Sumo Logic. So it automatically sets up the dashboards, the alarms, the burn down, the notification channel. All of that is done automatically with Terraform. And because they do this, this organization, their engineers never have a code freeze, blackout period. They can push to production at any time. They use service mocks. They do all of their performance testing. Specification limits are defined. They're tracked through the CI process. They're automating that in the pipeline, and they run those batteries of tests over and over and over and over again. They're looking for the deviations. CI is unified. It's idempotent, and it's managed by the SRE teams. And they completely destroy and rebuild their environments on a weekly basis, not because they have to, because they want to maintain that high capability of process. And they're going to the feature level in terms of logs, metrics, and traces. Everything's tagged in a common taxonomy. I hope you enjoy the content. Look, I think there's one slide on here that I must have fallen out. But, you know, elite performing teams, to be able to do DevSecOps and be able to move this, it's almost a matter of survival for many organizations now because the threat of disruption is so high. And so if you're not on that journey yet, if you're not measuring the DORA metrics, I encourage you to start. We have a great solution. It's called Software Development Optimization. We normalize all the data. It's high value, low volume. It's virtually free to bring in that data. I mean, it's so little, but you get all the dashboards, you get the DORA metrics by team, all of that rich data. Now you can start to measure your process of capability. And you can do that literally for any process, as long as you know what the voice of the customer is and you have a really articulate understanding of the voice of the process. I appreciate you guys being here. You are all true OGs. Thank you very much. Sorry for all the headaches at the very start of this. Thank you, AWS, for fixing the presentation for us. And I hope you guys have a great rest of the week. Thank you.